Hi students, this is Alex here. In this video, we are going to solve the sample paper Class 12 Mathematics Term 2. Section A has 6 short answer type questions of 2 marks each. Let's start the question number 1. We have integral log x by 1 plus log x whole square dx. We are going to rearrange this. In the numerator, we are going to add plus 1 and subtract plus 1 so that we get a similar term to the denominator. Already in the denominator we have 1 plus log x whole square. To get 1 plus log x in the numerator, we are adding and subtracting 1 in the numerator. Now we are going to group this, taking log x plus 1 as one term and minus 1 as the another term, and we are going to individually divide. That is log x plus 1 whole divided by 1 plus log x whole square, this is the first term, minus 1 by 1 plus log x whole square dx. Now we can cancel this 1 plus log x and this square. So we are left with only 1 by 1 plus log x. Let's split this integration into two parts. Let's take the first part as 1 by 1 plus log x dx, and another part is integral 1 by 1 plus log x whole square dx. Now we take the first integration and we are going to use integration by parts. So in this we are going to take this as one term, that is, and the another term is just 1 dx. So we have to write I late and we have to mark what are the terms present. The first term is log, we have 1 by 1 plus log x, and second term is 1 dx, 1 is algebraic. So we have two terms, one is logarithmic and algebraic. So whichever comes first, we take it as u. So 1 by 1 plus log x. And next term is dv, which is dx. From u, we have to find what is its derivative du. So this derivative is, we can directly use the chain rule. 1 by x derivative is minus 1 by x square. So minus 1 by 1 plus log x whole square, and by chain rule, the derivative of log x is 1 by x into dx. And from dv, we have to integrate and get b, which is nothing but x. So the formula is uv minus integral v du. So u is 1 by 1 plus log x into v is x minus integral v is x and du is minus 1 by 1 plus log x whole square into 1 by x dx. So we have done the first part, and the second part is written as it is, that is minus integral 1 by 1 plus log x whole square into dx. So minus integral 1 by 1 plus log x whole square into dx. Now we can cancel this x, and we can combine these two minus sign and make it as plus. So again rewriting this, the first term is x by 1 plus log x. This becomes plus integral dx by 1 plus log x whole square, and this is minus integral dx by 1 plus log x whole square, and at the end we put a integration constant c. So we find these two terms are same with opposite sign, so we can cancel these two. So the final answer is x by 1 plus log x plus c. Coming to the our question, we have integral sin 2x by root 9 minus cos power 4x dx. This we are going to rewrite as the numerator sin 2x. We are going to write the formula 2 sin x cos x, and in the denominator we are going to write it as 9 minus cos square x then whole square, and we have dx. Let's take t equal to cos square x d and dt equal to, using chain rule, its derivative is 2 cos x into cos x derivative is minus sin x dx. So totally, taking this minus to the other side, minus dt equal to 2, rearranging we get 2 sin x cos x dx. So this entire numerator is minus dt. So coming to the integration, integral minus dt by root of this 9 can be written as 3 square, and cos square x is t, but this is cos square x whole square, so this becomes t square. We have formula integral dx by root of a square minus x square equal to sin inverse x by a plus c. So this becomes minus bracket open sin inverse, in place of x we have t and in place of a we have 3. So minus sin inverse t by 3 plus c, and we have to replace the t, which is nothing but cos square x. So the answer is minus sin inverse cos square x by 3 plus c. Question number 2. They are asking to write the sum of order and the degree of the following differential equation. This can be rewritten as d by dx of dy by dx is d square y by dx square, which is given as 5. And this is the second order, so we can say order equal to 2. And this is the highest order present, and for this the whole power we don't have anything, so it is power 1. So we can say the degree is 1. So finally the sum of order and degree equal to 2 plus 1, which is 3. Question number 3. If a cap and b cap are unit vectors, so it means a cap magnitude equal to 1 and b cap magnitude is also 1. We have to prove a cap plus b cap whole magnitude equal to 2 cos theta by 2, where theta is the angle between them. Let's take the left hand side term, that is a cap plus b cap, but we are taking its square. We have a property where when there is a vector with magnitude square, this can be written as product of two vector, that is dot product of two vector. So if we apply this, this becomes a cap plus b cap dot a cap plus b cap. Now let's expand this by multiplying each term with the other two terms. This becomes a cap dot a cap plus a cap dot b cap plus again this is b cap dot a cap and b cap dot b cap. Once again, applying this property in the reverse way, when two vectors are connected with dot product, that can be written as the magnitude value, square of its magnitude value. So this is nothing but mod a cap whole square, and in dot product a cap dot b cap and b cap dot a cap both are same. It's commutative. So we can write 2 times of a cap dot b cap, and the last term once again b cap magnitude square. Already we have written from the question, these two are unit vector. So the first term and the last term can be replaced with this 1. So we get this is 1 plus 2 a cap dot b cap plus 1. So finally in the left hand side we have magnitude of a cap plus b cap whole square equal to, in the right hand side we have 1 plus 1 2 plus 2 times of a cap dot b cap. Now we are going to apply formula for a cap dot b cap. So once again all these things are written as it is. A cap plus b cap magnitude whole square is equal to 2 plus 2, and we have a formula whenever we have a vector dot b vector, that can be written as magnitude a vector magnitude b vector into cos theta. So if we apply this formula here, this is magnitude of a cap then magnitude of b cap into cos theta. As already we know, magnitude of a cap and magnitude of b cap is 1. So substituting that, we get finally 2 plus 2 into 1 into 1 into cos theta. Anyway, the last term is only 2 cos theta. Now 2 can be taken out common. This becomes 1 plus cos theta. And finally, left hand side we have a cap plus b cap magnitude whole square is equal to 2 into, we are going to apply the trigonometric formula for this. 1 plus cos theta is 2 cos square theta by 2, and when we remove the square, this becomes magnitude of a cap plus b cap equal to, here we have 2 into 2 4. When we remove square, it means we are taking the square root on both the sides. So this becomes 2, and cos square theta by 2 becomes cos theta by 2. Usually when we take square root we get plus or minus, but since the left hand side has a magnitude, this has to be positive. So we take only the positive value, ignoring the negative value. So we get a cap plus b cap magnitude equal to 2 cos theta by 2. Hence proved. Question number 4. Find the direction cosines of the following line. They have given the line and this has to be written in a standard form, that is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So coming to the first term, we have 3 minus x. So by taking the minus sign outside, this becomes minus of x minus 3 divided by minus 1. And here we have to take 2 common, because in the standard form we notice we have only x, y and z term without any coefficient other than 1. So by taking 2 out, we get y minus 1 by 2 whole divided by 2. And the last term is just written as z minus 0 by 4. Now we can cancel these two minus and these two. Again, by rewriting this, we get x minus 3 by 1 equal to y minus 1 by 2 by 1 equal to z minus 0 by 4. So we got into the standard form, and from this the direction ratios are this denominators small a, b and c. So we take it as 1, 1, 4. Now from the direction ratios, to find the direction cosine, you have to find the magnitude of these values, that is root of 1 square plus 1 square plus 4 square. So this becomes 1 plus 16, which is root 18, that can be written as root of 9 into 2. When we take square root for both the numbers individually, we get root 9 into root 2, and that gives 3 root 2. And for direction cosines, we have to divide every value by this magnitude and that gives 1 by 3 root 2. Again, the next value is 1 by 3 root 2, and the last value is 4 by 3 root 2, and we enclose with this angle bracket. So this is our required direction cosines. Question number 5. A bag contains 1 red and 3 white balls. Let's write it here. The number of red ball is 1, number of white ball is 3. So totally we have 4 balls. We have to find the probability distribution of the number of red balls if 2 balls are drawn at random from the bag one by one without replacement. So we are going to take 2 balls and we have to find the probability distribution for the number of red balls. The random variable x is 0, 1, 2. Since we are taking 2 balls, the random variables are 0, 1 and 2. But in this case, out of 2, both are not red is possible, and out of 2, 1 red is possible, but both are red is not possible because already here we have only 1 red. So in this case, this 2 will not come because this probability is 0. So now the random variable is only 0 and 1. Let's find probability for the first value, which is 0. 0 means both are not red. It means both comes from this white. There are 3 white. From the 3 white we get 2 balls, and the denominator is out of the 4 we take 2. So 4C2. Since it is without replacement, we can use combination directly. So from 3 we are getting 2. Then only there will not be any red ball. So finding this value, this is 3 into 2 by 1 into 2 whole divided by 4 into 3 by 1 into 2. We can cancel these 2 and we can cancel 3 and 3. Cancelling 2 and 4, we get answer as 1 by 2. Then probability of x is equal to 1. It means 1 red. 1 red will come from this available 1 red. So it is 1C1 into, and we are picking 2, and 1 more will come from this W, which is 3C1 divided by total probability is 4C2, because from 4 totally we are taking 2 balls. So 1C1 is 1, 3C1 is 3 divided by 4C2 is 4 into 3 by 1 into 2. We can cancel these 2 and we can also cancel these 2. So this is 1 by 2. Now the probability distribution, we have to write x and corresponding probability value. The value of x is 0 and 1, and the corresponding probability is 1 by 2 and 1 by 2. This is our probability distribution table. We can verify this whether it is correct or not by adding all the probability, and the total probability should be 1. By adding the probability value 1 by 2 and 1 by 2, we get 1. So hence we find this is correct. Question number 6. 2 cards are drawn at random from a pack of 52 cards, one by one, without replacement. What is the product of getting first card red and second card jack? Out of the 52 cards, we have spade, club, then heart, then diamond. So in each we have 13, 13, 13, 13. So total we get 52. In this, these two are red color, and in every suit there is a jack present. So there is a black jack as well as there is a red jack. Now as per the question, we need the probability of first card is red and second card is jack. So there are two possibilities. When we pick red, it can be the red card, which can be a jack or non-jack. So let's write it here. So probability of, we are picking the red, but it is non-jack red. and we are going to get the second as jack. Or there is another possibility that the first card is jack and it is also red, and again the second one is jack. So these are the two possibilities. The second is always jack, the first is always red, but the thing is whether it is a jack red or non-jack red. So we have to split into two parts like this. Now coming to its probability value, non-jack red means the jack is not present among this red card. So there are totally 52 cards. In that we are looking for the red, but without the jack. There are 26 cards, red cards, because everything is 13. So here the total number of red cards is 26 and total number of black is 26. But here it is a non-jack. So these two red jacks are excluded. So from 26 minus 2 we get only 24. Then coming to the second jack into, now one card is taken already. Now as per the question, it is not replaced, without replacement. So the total number of cards will decrease by 1. So it is 51 now. And we are looking for the jack. Already the first part did not include any jack. So 4 jack cards will be available as it is. So out of the 51, there is a possibility of getting 4 jack. Now coming to the second part, it is the red card out of 52, but it is a jack. So there are only 2 jack present in the red. So it is 2 here into. Now one card is taken which is not replaced. So remaining is 51. Out of that we are going to pick the jack, but already the first card drawn is also jack. So out of the 4 jacks, one card is removed, that is one card is selected already. So now we have only 3 cards remaining. So the second card jack is 3 out of 51. Now we can simplify as much as possible. We can cancel this 4 and this 52, that gives 13 times. Here this 2 and 56, 26 times. Then this 3 and 51, 3 ones are 3, balance 2 is remaining, 7 times 21. So this is 17. And this one with 3 if I cancel, this is again 17 and this becomes 8 times. So finally we have 8 by 13 into 17 plus 1 by 26 into 17. We find 13 and 17 common in the denominator. So numerator is only 8 in the first term, and here when 13 is common, the remaining is only 2. So we put 1 by 2. So this part is 1 by 13 into 17. We take LCM, it is a 16 plus 1. So we get 17 by 2, which can be cancelled here. So 1 by 13 into 17 by 2. By cancelling 17 and 17, we left with 1 by 13 into 2, which is 1 by 26. Now coming to section B, we have 4 short answer type questions of 3 marks each. Question number 7, integral x plus 1 by x square plus 1 into x dx. We are going to apply the partial fraction method. Let's take the expression x plus 1 by x square plus 1 into x. As per the partial fraction rule, when we have a non-factorizable quadratic, we have to write linear term in the numerator. So ax plus b divided by x square plus 1, and here we have the factor x. So this becomes c by x. So we use the partial fraction rule. Now we take the LCM. So the LCM is x square plus 1 into x. Now this part is multiplied with this x. So we get ax plus b into x plus, and this part is multiplied with c. So here it is c into x square plus 1. Now both the sides we have same denominator, so we are going to equate the numerator. So we get x plus 1 equal to ax plus b into x plus c into x square plus 1. Now let's take a value for x. Let x equal to 0. When I substitute 0 here, left hand side is 1 and this entire term becomes 0, and the second term is c into 0 plus 1. So totally the value of c is 1. So we got the value of c by taking x as 0. Now we are going to compare the coefficient of x square on both the sides. So comparing coefficient of x square on both the sides. In left hand side we don't have x square term, so it is 0 equal to, by multiplying this inside we get ax square. So the coefficient of x square is a, and here when I multiply c inside it is cx square. So a plus c is the total coefficient of x square on the right hand side. Already we know the value of c as 1. By substituting this we get 0 equal to a plus 1, and from this the value of a is minus 1. So we got the value of a and c. In the same way we can also compare the coefficient of x on both the sides. So in the left hand side we have x plus 1. So the coefficient of x is 1, and on the right hand side if we see, when we multiply this x inside here we get b. So we take b here, and coming to the second term there is no x term. So totally the value of b is 1. So we got the value of a, b and c. After getting the value of a, b and c, we have to substitute in the place where we applied the partial fraction rule. That is ax plus b by x square plus 1. So this is minus 1x plus 1 by x square plus 1, and c, the value of c is 1. So 1 by x, and we have to take integral and dx. Now this has to be split into two parts, minus x by x square plus 1 dx. This is one integration, and second part is 1 by x square plus 1 into dx, and the last part is integral 1 by x dx. Now let's take this as I1, I2 and I3. Now coming to the I1, we have to take t equal to x square plus 1. So from this the value of dt is 2x dx, but in the numerator we have only x dx. So dt by 2 is x dx. So by substituting everything in terms of t, this becomes minus dt by 2 by t. Taking minus 1 by 2 outside, we get minus 1 by 2 integral dt by t, which is log t. So this is minus 1 by 2 log mod t plus c, and we have to replace the value of t, which is log mod x square plus 1 plus, let's take it as c1. Now coming to I2, this is a direct formula, and I3 is also direct formula. So I2, the integration of 1 by x square plus 1 is tan inverse x, and we have to take an integration constant c2. And coming to I3, this is also direct formula, 1 by x integration is log x, log mod x plus c3. Now combining all the three, we get the total value as I equal to minus 1 by 2 log of, since x square plus 1 is always a positive number, it is not necessary to put the modulus, and second term is tan inverse x, and third term is log mod x, and altogether in place of c1, c2 and c3 we can put a single constant c. Question number 8. We have to find the general solution of the following differential equation. Let's take the expression. We have x dy by dx equal to y minus x sine of y by x. Whenever we find y by x or x by y as an inner function, we can confirm that it is a homogeneous method. For homogeneous method, we always need dy by dx equal to. So let's write dy by dx equal to taking this x term to the other side denominator. So we get y minus x sine of y by x whole divided by x. By dividing individually, the first term is y by x and second term we can cancel this x, so we left with only minus sine of y by x, and on the other side we have dy by dx. And as per the homogeneous method, we have to take y equal to vx and dy by dx equal to, using product rule, v into derivative of x is 1 plus x into derivative of v is dv by dx. Now we have to substitute these two in dy by dx expression. That is, in this place, in left hand side, instead of dy by dx, we are going to substitute this value, that is v plus x into dv by dx, and right hand side, in place of y, we have to substitute vx in these two places. So this is vx by x minus sine of vx by x. So we can cancel this x and x and this x and x. So finally we have v plus x into dv by dx equal to v minus sine v. Even we can cancel v and v. If I take this v to the other side, it becomes minus, so it gets cancelled. Then after this step, we have to do variable separable. X into dv by dx equal to minus sine v. Taking v terms to one side, dv by sine v equal to, we keep this minus sign here, and dx by x. Now taking this to the numerator, it is cosecant v dv equal to minus dx by x. After variable separable, we can integrate on both the sides. The direct formula, integration of cosecant v is log mod cosecant v minus cot v, and on the other side it is minus log x. Since both are log, we can take, instead of a constant c, log c. So now this log terms can be combined. This can be written as log c minus log x, that is log a minus log b is log a by b. So this is log c by x, and on the other side we have as it is log mod cosecant v minus cot v. Now we can remove log on both the sides. So we have modulus of cosecant v minus cot v equal to c by x. By removing this modulus, it becomes cosecant v minus cot v equal to plus or minus c by x, and this x can be taken to the other side. So this is x into cosecant v minus cot v equal to plus or minus c. And here, instead of c, if I take c1 from the starting, we get plus or minus c1, and that can be replaced as c. And we have to replace the value of, that is the expression for v. From the substitution, when y equal to vx, v is y by x. So we are going to replace it here. So this is x into cosecant y by x minus cot y by x equal to c. Plus or minus c1 is taken as c. Coming to the R question, we have to find the particular solution of the following differential equation. And the condition is y equal to 0 when x is equal to pi by 4. The given expression is dy by dx plus y cot x equal to 2 by 1 plus sin x. Let's take the question here. Dy by dx plus y cot x equal to 2 by 1 plus sin x. This is of the form dy by dx plus py equal to q. So from this we know p is cot x. P is the term which is with y. Similarly, cot x is the term with y. So we take p as cot x and q is the term which is on the right hand side. 2 by 1 plus sin x. Now we have to find integrating factor. The formula is e power integral p dx. So e power integral cot x dx. Integration of cot x direct formula log sin x. So e power log sin x and e power log that will get removed and we left with only sin x. Now solution for this is y into integrating factor equal to integral q into integrating factor into dx plus c. Now this is y into sin x equal to integral q is 2 by 1 plus sin x. So 2 by 1 plus sin x into this is again sin x dx plus c. Now left hand side is y into sin x. Right hand side we can take 2 out. The numerator is sin x and denominator is 1 plus sin x. We add 1 and subtract 1 with the numerator and we are going to group the terms taking these two together and minus 1 separately. So this is 2 integral sin x plus 1 by 1 plus sin x and minus 1 by 1 plus sin x dx, and then we have plus c. The first part after cancelling it becomes 1 and second part we have minus 1 by 1 plus sin x. We can multiply by its conjugate 1 minus sin x with both numerator and denominator and then we have dx plus c. So totally this is 2 integral 1 minus, we have 1 minus sin x in the numerator and denominator it is like a plus b into a minus b. So 1 minus sin square x which is cos square x and we have dx. This minus is common so we keep a separate bracket. So left hand side we have y into sin x equal to 2 integral, this is 1. When I divide individually by taking 1 by denominator minus sin x by denominator, when we divide individually 1 by cos square x and next will be this minus is taken inside, so it is sin x by cos square x and at the end we have dx then plus c. So y into sin x 2 integral 1 minus this is secant square x, 1 by cos square x is secant square x and sin x by cos x can be taken as tan x and there is one more cos x remaining in the denominator that is taken to the numerator, it is secant x. So sin x by cos square x, let me write it here, is written as sin x, cos square x is written as cos x into cos x, and this part is written as tan x, and this 1 by cos x is, when cos x is taken to the numerator, it is tan x. And then we have dx. Now we are going to integrate each term. So this is 2 open bracket, 1 integration is x, secant square x integration is tan x, and integration of secant x tan x is secant x. So plus secant x plus c, and we have y into sin x. To find the c, we have to use the condition given, which is when y is 0, x is pi by 4. Let's write it here. The condition is y equal to 0 and x is equal to pi by 4. When y is 0, this left hand side is fully 0. Right hand side we have 2 into the value of x is pi by 4 minus tan pi by 4 is 1 and secant pi by 4 is root 2, because cos pi by 4 is 1 by root 2 and it's reciprocal. Then plus c. By multiplying this 2 inside, we get pi by 2 minus 2 plus 2 root 2. This is plus c. By taking all these terms to the other side, c becomes, this 2 becomes positive minus 2 root 2 minus pi by 2. The c value we have to substitute in this general solution to get the particular solution. So we are going to write once again everything as it is, y into sin x. So final solution is y into sin x equal to, so this is equal to 2 bracket open, we have x minus tan x plus secant x, x minus tan x plus secant x, and the value of c, which is 2 minus 2 root 2 minus pi by 2. Question number 9. They have given a vector is not a 0 vector, and the condition is a vector dot b vector equal to a vector dot c vector, and a vector cross b vector equal to a vector cross c vector, and we have to prove b vector equal to c vector. Let's take the first condition, where a vector dot b vector is equal to a vector dot c vector. From this, I take this term to the other side, so it will become a vector dot b vector minus a vector dot c vector equal to 0. Now we can take a vector common, so a vector dot b vector minus c vector equal to 0. Now from this we can have 3 conditions, that is, when dot product is 0, either a vector equal to 0 vector, or the other one b vector minus c vector equal to 0, or both are perpendicular, that is, a vector is perpendicular to b vector minus c vector. When they are perpendicular, dot product is 0. So we have 3 conditions. In the same way, let us take the other condition, that is, a vector cross b vector equal to a vector cross c vector. Now taking this to the other side, a vector cross b vector minus a vector cross c vector equal to 0. Now taking a cross common, a vector cross bracket open b vector minus c vector equal to 0. Since this is the cross product and the result is a vector, so we have to put a 0 vector here. But in the previous one it is a dot product, so it is a scalar. The answer is a scalar, so we can put only 0. Now from this, again, when cross product is 0, we have 3 options. Either the first vector is 0 vector, or the second part is 0, that is, b vector minus c vector equal to 0, or Even this can be written as a perpendicular, that is when A vector, parallel, that is when A vector is parallel to B vector minus C vector, then the cross product is 0. So we have these three conditions. But already in the question they have given A vector is not equal to 0. So we are going to state this here. Given A vector is not equal to 0 vector. So already there is a condition A vector is not equal to 0. So from this condition, this option is eliminated in both the case. At the same time, two vectors, one is A vector, another is B minus C. So both cannot be perpendicular and parallel at the same time. Any one only possible. So we can say A vector cannot be perpendicular and parallel to B minus C at the same time. So this reason is also eliminated. So the only reason left out is B vector minus C vector equal to 0 vector or 0 in both the cases. So from this, even if you put a vector symbol here, it is fine. So therefore the only reason is B vector minus C vector equal to 0 vector. From this we can say B vector equal to C vector. So as per the question, we have to show B vector equal to C vector, hence proved. Question number 10, first part, we have to find the shortest distance between the following lines. They have given two lines. The first line equation is R vector equal to I plus j minus k cap. So the equation of the line in the general form is R vector equal to A vector plus SB vector. Since we have two lines, let's take this as A1 and B1. So we will take A vector as the first part, I cap plus j cap minus k cap. This is A1, and B1 is the second part, which is 2I cap plus j cap plus k cap. In the same way, from the second line, let's take A2 and B2. This is A2 vector equal to I plus j plus 2k, but we notice when we take 2 common from this, it will be similar to the B1. So when I write B2 vector, first let me take as it is 4I cap plus 2j cap plus 2k cap. We notice B2 vector equal to 2 times of B1 vector. Therefore, B1 and B2 both vectors are parallel. So we will take the simplest one and we take it as a B vector. So B vector equal to 2y plus j plus k. Instead of B1 and B2, we have to take it as B. Since these two are parallel, the shortest distance between two parallel lines by formula, it is A2 vector minus A1 vector cross B vector whole divided by mod B vector, and everything is under the magnitude. Now let's substitute the values. That is A2 minus A1. We have to subtract this A2 minus A1. So I minus I 0, j minus I 0. 2k minus of minus k will become 3k. So the first part is 3k cap cross, and B is 2I cap plus j cap plus k cap, and in the denominator we have magnitude of B, which is root of 2 square 4 plus 1 plus 1, and we have whole magnitude, and we have to do cross product. Generally we use determinant, but since this is a single term, we are going to directly multiply this with every term. Now 3 2s are 6, and k cross I is j cap. Then 3 1s are 3, and k cross j is minus I cap, and the last is k cross k, which is 0. Now in the denominator we have root 6 and we have magnitude like this. Now we can take this denominator 1 by root 6 separately, and in the numerator we have to find the magnitude of 6j minus 3i, 6j cap minus 3i cap. Let's rearrange this. We can also take 3 common, and when 3 is common, I component is just minus I cap and plus 2 j cap, and we have to find the magnitude for this. Now 3 by root 6 can be kept separately. In root of coefficient of I cap is minus 1, we have to square this by finding the magnitude, and j cap is 2, so we have to square. So finally this is 3 root 1 plus 4 by root 6. On simplifying this, 3 root 5 by root 6. Since it is a distance, we represent this value by units. Next, our question. Find the vector in the Cartesian equation of the plane. So there is a plane. We have to find this plane's vector and Cartesian equation. Let's take a small diagram. This is a plane and it contains the point. The point is given in the vector form I cap plus 2j cap minus k cap. Let's take the point somewhere in the plane as 1, 2, minus 1. And this is parallel to, they have given 2 lines. Let's draw 2 lines. One is here and another line here. Both are parallel to this given plane. And we have to draw the normal of the plane. Normal of the plane is a line which is perpendicular to the plane surface. And let's take this as line 1 and this as line 2. And line 1, we are going to write only the direction ratio from here. That is 2, minus 3, 2. And for line 2, again the direction ratios, we are going to take its coefficient 1, minus 3 and 1. Now we are going to write the equation of the plane in the general form. So equation of plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Now the plane contains this point, so we have to substitute for x1, y1 and z1. So this gives a into x minus 1 plus b into y minus 2 plus c into z plus 1 equal to 0. Now these two lines are perpendicular to the normal of the plane. So we are going to use perpendicular condition by taking this first dr as b1 vector and this dr as b2 vector. So let's write it here. b1 vector is, it is actually writing in terms of ijk, we get back the same thing. 2i minus 3j plus 2k. 2i cap minus 3j cap plus 2k cap, and b2 vector from the another line I minus 3 plus k. I cap minus 3j cap plus k cap. Now we are going to find b1 vector cross b2 vector. For this we take a determinant. First row is I, j, k. Second row is 2 minus 3 2 component of b1. Third row is component of b2 which is 1 minus 3 1. Now we are going to expand this determinant. We take the first element and taking this will be minus 3 plus 6. Then minus j into 2 minus 2 plus k cap into minus 6 plus 3. So totally this is 3 I cap. This becomes 0 plus 0 j cap and this is minus 3 k cap. And from this the value of ABC which we have to substitute in this equation are nothing but the coefficient of this vector, that is 3, 0 and minus 3. So let's take it separately. Therefore A is equal to 3, B equal to 0, C equal to minus 3. Substituting this we get 3 into x minus 1, 3 into x minus 1, second part is 0 anyway, so 0, and the third part is minus 3 into z plus 1 which is equal to 0. This is 3x minus 3 minus 3z minus 3 equal to 0. Now rearranging this, 3x minus 3z minus 6 equal to 0. We can divide by 3. X minus z minus 2 equal to 0. This is our equation of the plane in the Cartesian form. Now writing this into the vector form, it is r vector dot, from this it is I cap plus 0 j cap minus k cap minus 2 equal to 0. We can take this 2 to the other side. So r vector dot I cap minus k cap equal to 2. This is our required equation of the plane in the vector form. Next one, section C, we have 4 long answer type questions of 4 marks each. Question number 11. We have to integrate from minus 1 to 2 modulus of x cube minus 3x square plus 2x dx. Since it is inside the modulus, we have to know in which region from minus 1 to 2 this entire expression is positive and in which region it is negative. For that we have to take this expression alone and factorize it. We can take x common. Now it is x square minus 3x plus 2, and factorizing this quadratic we get x into x minus 1 into x minus 2. When we equate this to 0, by equating individual terms to 0, we get x is 0, 1 and 2. And we have to plot these values in the number line from minus 1 to 2. So already minus 1 is here, so 0 will come somewhere here, 1 will come here, and 2 is already at the end of the number line. Now we have to find out in which region it is positive and which region it is negative. Let's take a value between 1 and 2. For example, 1.5. We have to substitute in this factor and we have to check whether it is positive or negative. If I put 1.5, it is positive. If I put 1.5, then 1.5 minus 1 is again positive. 1.5 minus 2 is negative. So totally it is a negative value in this region. Now coming to this part, let's take 0.5 and substitute here. If I substitute 0.5 here, first value is positive, 0.5 minus 1 is negative, and 0.5 minus 2 is also negative. So two negatives, so totally it becomes positive. In the same way, let's take in this region minus 0.5. So in the middle region we have taken 0.5 The value which we are taking should be within the region here. So we take minus 0.5. If I substitute minus 0.5 in this place, so first term will become negative. Minus 0.5 minus 1 is again negative. Third also negative. 3 negative. Totally it is negative. In this region it is negative. So we are going to write this integration into three parts. The first part is from minus 1 to 0, and in this region it is negative. Instead of modulus I have to put minus sign. So x cube minus 3x square, and the last one is plus 2x. The total value is negative, then dx, and the second part is positive. So instead of modulus I have to take a positive sign. So plus integral, and the second region is from 0 to 1. First region is from minus 1 to 0, second is from 0 to 1. Again the same expression with positive sign. So x cube minus 3x square plus 2x dx. And third is once again negative from 1 to 2. So plus, but we can directly write the minus sign. Instead of plus, we take minus integral 1 to 2, and we have to copy the expression x cube minus 3x square plus 2x dx. Now coming to the first part, there is a minus sign, open bracket, and we are going to integrate this entire expression. X cube is x power 4 by 4 minus 3 into x square is x cube by 3, then 2x is 2x square by 2, and the limit is from minus 1 to 0. Then the second part is, again we have to copy everything as it is, but the limit is from 0 to 1. Third part also same. Open a square bracket, x power 4 by 4 minus 3x cube by 3 plus 2x square by 2, 1 to 2. Now we are going to apply the limit. Before that we can cancel 3 and 3, 2 and 2 in every term, so that it is easier to substitute the limits. So we have a minus sign, open bracket. When I put 0, the upper limit for all the term, everything becomes 0. Then minus of, when I put lower limit, which is minus 1. When I put minus 1 here, it is 1 by 4. This becomes plus 1, and this becomes again plus 1. Then coming to the second part, when I put the upper limit, it is 1 by 4 minus 1 plus 1. Then minus, when I put lower limit, everything is 0. So we can put only 1, 0. In the last one, there is a minus sign. When I put 2, 2 power 4, 16, 16 by 4 is 4. Minus 2 cube is 8. Plus 2 square is 4. Minus, when I put the lower limit, 1 by 4 minus 1 plus 1. Now, we can take this minus sign here. It will become positive. So 1 by 4, we can add 1 plus 1, that gives 2. Here we can cancel these 2. We left with 1 by 4. Then 4 plus 4 is 8. 8 minus 8, everything gets cancelled. And we can make this as positive. So plus 1 by 4, and we can cancel plus 1 and minus 1. So we have only 1 by 4 left. Totally, there are 3 1 by 4, which is 3 by 4 plus 2. We take LCM, which is 4. So here 3 plus 4 are 8. Totally this is 11 by 4. Question number 12. Using integration, we have to find the area of the region in the first quadrant enclosed by x plus y equal to 2, the line, and the parabola y square equal to x and the x-axis. Let's take this line. We have x plus y equal to 2. For plotting this, I have to choose x and y values when x is 0 and y is 0. When x is 0, when I put 0 here, the value of y is 2. When y is 0, the value of x is 2. So, from this, we get 2 points, and using those 2 points, we can plot the rough graph. and the 2 points are x comma y, that is 0 comma 2 is one point and 2 comma 0 is the another point. Then we have the parabola y square equal to x. This parabola is open right side. So now we go for the diagram. We take x axis and y axis, and this parabola open right side something like this. It is symmetrical about the x axis and it is open right side. And this line is 0 comma 2. 0 comma 2 will be somewhere here and 2 comma 0 will be somewhere here. So when we join this, we get a line like this. And even this line can be extended. But as per the question, they are asking the area of the region in the first quadrant only. Now we will plot this points here, that is origin is 0 comma 0 and this point is 2 comma 0, and this meeting point we have to drop from this. Since these two curve meet at this point, let's equate both the y. From the line, the value of y is 2 minus x. From the parabola, y square equal to x. Now in place of this y, we have to substitute 2 minus x. So 2 minus x whole square equal to x. Let's expand this. 4 minus 4x plus x square equal to x. Let's take this to the other side. So we get x square minus 5x plus 4 equal to 0. Now factorizing this, we get x minus 1 into x minus 4 equal to 0. It means there are two values of x, 1 and 4. But when we extend this parabola, the parabola line will meet at another point, that may be 4. But here it is, the value of x is 1. So this point is 1 comma 0. When I substitute this x value 1 in this line, then 2 minus 1 is 1. So this point is actually 1 comma 1. Anyway, that point is not needed. We need only the points on the x-axis to get the limit. So this is one region, and we have to find the area of this region. So separately we are going to find this and add. But before that, we have to write the value of y in both the curves. So from this, the value of y, it is a parabola, y square equal to x. So from this, the value of y is root x, and from this the value of y is 2 minus x. So first we will take the limit from 0 to 1. 0 to 1, this is the top boundary. So we have to write that equation. So now the total area is integral 0 to 1 and top boundary equation is root x then dx. Then with that we have to add the other part. This is from 0 to 2 and this top boundary is 2 minus x. So let's take integral from 1 to 2 and 2 minus x into dx. Therefore, integration of root x, root x is x power half. By integration, it is x power 3 by 2 by 3 by 2. That by 3 by 2 can be written as 2 by 3. We have to substitute the limit 0 to 1. And this is 2x minus x square by 2. And limit is from 1 to 2. When I substitute the upper limit, it is 1 and lower limit is 0. Here when I substitute the upper limit, 4 minus, when I put 2 here, it is 4 and 2 square is 4, 4 by 2 is 2. When I put the lower limit, 2 minus 1 by 2. Now totally, the first part is 2 by 3 and second part is 2. When I take this minus inside, minus 2 plus 1 by 2, we can cancel these two. So finally we left with 2 by 3 plus 1 by 2, LCM is 6. So this will be 4 plus 3 and that is 7 by 6. Since it is area, we have to mention square units. Now coming to the R part, we have to find the area of the region using integration. The region is given in inequalities form. Let's take the first part of this inequality, 0 less than or equal to y less than or equal to root 3x. From this, we get an equation y equal to root 3x. Similarly, the second part is circle x square plus y square equal to 4. Now this is a line, and if we plot in the graph, we get a straight line passing through the origin, and when we compare this with the general form y equal to mx, the value of the slope is root 3. So the line is inclined at an angle 60 degree like this. So this is y equal to root 3x. And this is a circle with center, origin and radius 2. So we take the diagram like this. Now this part is origin. So 0, 0. And this part is the radius of the circle, which is 2, 0, because this line length is 2. Now we have to find out in which region area we have to find using this inequality. And in circle it is given less than or equal to, so everything is inside the circle. But whether it is this region or this region, we have to find out. For that, let's take this inequality. First part, y is less than or equal to root 3x. Let's take some point here. This point is 1, 0. When I substitute 1, 0 here, y is 0 less than or equal to root 3. 0 less than root 3 is true. It means this side of the line is true. So the region which I have to consider is only this part. So we have to choose a point on one side of the line. If that satisfies the inequality, the region is on the same side. Otherwise it is on the other side. So we confirmed this is the region we have to find. And we have to drop this meeting point. And in both the curve, we have to write y. From this, the y is equal to root 3x. And from this, y is, from here I have to take root of 4 minus x square. We have to find this meeting point. For that, we have to equate both the y. That is root 3x equal to root of 4 minus x square. Squaring on both the sides, 3x square equal to 4 minus x square. Taking this to the other side, 3x square plus x square. So 4x square equal to 4. From this, we get the value of x as plus or minus 1. But since we deal with the first quadrant, we take this point as 1 alone. So this is 1, 0. When I substitute 1 in any of the equation, we get y as root 3. So this point is 1, root 3. Now coming to this region, we have two parts. One is from 0 to 1. 0 to 1 is a limit, and this top boundary is this equation. And 1 to 2 is this region, and the top boundary is y equal to root 4 minus x square. So we are going to write this in the integration. Area equal to integral 0 to 1 root 3 x dx and 1 to 2 root of 4 minus x square dx. Now this is root 3 into x square by 2. After integration, we have to substitute the limit from 0 to 1, and this is the formula: x by 2 into root of 4 minus x square plus 4 by 2 into sine inverse x by 2, and the limit is from 1 to 2. Now let's substitute the upper limit, which is 1 by 2, and lower limit is 0. When I substitute 2 in place of this x, first term is 0 and second term is 4 by 2, which is 2, sine inverse 1. Then coming to the lower limit, 1 by 2, and this becomes root 3. So we take root 3 here, plus 4 by 2 is 2, and now sine inverse 1 by 2, bracket close, and the big bracket close. Finally, this is root 3 by 2, and this is 2 into sine inverse 1 is pi by 2, and when you take the minus inside, minus root 3 by 2 minus 2 into sine inverse 1 by 2 is 5 by 6. So we can cancel these two, even these two, this will become 3. Now totally this is root 3 by 2 plus 5 minus root 3 by 2 minus 5 by 3. So we can cancel root 3 by 2 minus root 3 by 2. 5 minus 5 by 3 after taking LCM we get 2 pi by 3. Since it is area, we have to say 2 pi by 3 square units. Question number 13. Find the foot of the perpendicular from the point upon the plane. We have a plane. Usually plane we take a parallelogram shape. So we have a plane like this. And there is a point 1, 2, 0 above this. We have to find the foot of the perpendicular. So we have to drop this to the plane perpendicularly. The point where it meets is the foot of the perpendicular. Let's take this point as P and this is A, and the equation of the plane is x minus 3y plus 2z equal to 9. Since we are going to find the point A, which is the foot of the perpendicular, let's take that point as x1, y1, z1. Now we are going to find the direction ratio of the line PA. It is nothing but the difference between these two. x1 minus 1, y1 minus 2, z1 minus 0. Now this line itself is a normal to this plane whose direction ratios are nothing but the coefficient from the plane equation. Those are 1, minus 3, 2. Let's write direction ratio of normal of the plane, which is 1, minus 3 and 2. Since these two are same, we can use a parallel condition. Using parallel condition, the parallel condition is nothing but A1 by A2 equal to B1 by B2, which is equal to C1 by C2. Now from this we get x1 minus 1 divided by 1. So we are going to divide correspondingly. And the second part is y1 minus 2 by minus 3. And third part is z1 minus 0, z1 itself divided by 2. And this we are going to equate to k. Now equating individual terms to k, we are going to get x1 minus 1 by 1 equal to k. From this, x1 minus 1 is equal to k, and the value of x1 is k plus 1. In the same way, equating this y term to k, we get y1 minus 2 by minus 3 equal to k. So y1 minus 2 equal to minus 3k, and y1 is minus 3k plus 2. In the same way, z1 by 2 equal to k, and by cross multiplying, z1 equal to 2k. We got the values of x1, y1 and z1, and these three values is nothing but the point A, which is lying in the plane itself. So we are going to substitute this in the plane equation. Now let's write substituting in the plane equation. Let's copy the plane equation. X minus 3y plus 2z. X minus 3y plus 2z equal to 9. Now the value of x1 we are going to substitute here, which is k plus 1, then minus 3 into y is minus 3k plus 2 plus 2z. So 2 into 2k, which is equal to 9. So from this is k plus 1. By multiplying minus 3 inside, we get plus 9k minus 6, then plus 4k equal to 9. Now combining this, k plus 9k is 10k plus 4k is 14k, and these two together is minus 5, which is equal to 9. Now 14k equal to, taking this minus 5 to the other side, 9 plus 5, which is 14. From this the value of k is 1. When we substitute the value of k in x1, y1 and z1, we get the fifth other perpendicular. x1 is k plus 1. So k plus 1 means it is 2. And y1 is minus 3k plus 2. So y1 will be minus 1. And I substitute 1 here, it will become minus 1. And here it will become 2. z1 is 2. So therefore the point A, which is the foot of the perpendicular, is 2, this is 2. When we substitute k as 1, 2k becomes 2. So the point A, which is foot of the perpendicular, is 2, minus 1, 2. Now there is another part of the question where they are asking to find the distance of the point from the given plane. So they want the distance between these two. Here we can straight away use the perpendicular distance formula. So perpendicular distance, we have a formula which is ax1 plus by1 plus cz1 plus d whole divided by root of a square plus b square plus c square within the modulus. We can either use this or we can use the distance formula between 2 points. Since we know the coordinates of A, we can find the distance PA. But here we are going to use this, and here the capital A, B, C, D is from the plane equation x minus 3y plus 2z equal to 9. We take the coefficient of x, y, z and the constant term, which is, let's write it here before substitution. Let's write what is A, the coefficient of x, which is 1. Then b is the coefficient of y, which is minus 3, and c is the coefficient of z, which is 2, and d is, when the 9 is taken to this side, left side, it becomes minus 9. And the value of x1, y1 and z1 is nothing but from the point which we are finding the perpendicular distance. The point is 1, 2, 0. So this value is 1, 2, 0. We are going to substitute all these values in this formula. So a into a is 1, x1 is 1. Then b is minus 3 into y1 is 2. And c is 2 and z1 is 0. And the last value d is minus 9 whole divided by root of a square plus b square plus c square, and we have to take a magnitude because the distance cannot be negative. So this is 1 minus 6 minus 9 whole divided by root 14 within the magnitude. Now the numerator itself minus root 14 by, the numerator is minus 14, denominator is root 14. Since within the magnitude, we can take only the positive value, root 14 by root 14, and this after cancelling we get root 14. Since it's the distance, we have to write root 14 units. Question number 14, which is a case-based or data-based question. An insurance company believes that people can be divided into two classes, those who are accident prone and those who are not. Let's take E1. Those are accident prone, and E dash is the another class of people, those are not accident prone. Then further reading the question, the company statistics shows that an accident prone person will have an accident at some time within a fixed year, fixed 1 year period with a probability 0.6. Let's take the accident as A. So after naming all this, there is a accident prone person. So we have to write this in the denominator, and the probability of the person will have an accident is 0.6. So A we have to write here, and this value is 0.6. Then whereas the probability is 0.2 for a person who is not an accident prone. So the probability of the person who is not accident prone is E2. He is meeting with an accident is 0.2. And further reading the question, the company knows that 20% population is an accident prone. So accident prone we have named as E1. So P of E1 is 20%. It means 20 by 100. And P of E2 will be the remaining, because there are only two classes of people. So that will be 80 by 100. Now coming to the question, the first one is, what is the probability that the new policyholder will have an accident within a year of the purchasing a policy? They are asking for the probability of accident. It means the accident can happen to any of the two classes of the people. So if you take probability of accident, it is nothing but it is the person who is prone to accident, and that person is meeting with an accident, or it is the person who is not prone to accident, but the person who is not prone to accident is meeting with an accident. So these are the two possibilities where the accident can happen. Now we have to substitute the value. This is 20 by 100, and this one is 0.6, and E2 is 80 by 100, and this is 0.2. Now we can take a common denominator 100, 20 into 0.6, 6 2s are 12, and we have to put one 0, and we have to move one decimal, so it is only 12. 8 2s are 16, and since it is 80, we have to put one 0, and we have to move one decimal. So totally it is 12 plus 16, 28 by 100. By cancelling with 4 table, this becomes 7 by 25. Now coming to the second subdivision, it is given, suppose a new policyholder has an accident within a year. So we know accident happened. What is the probability that he or she is an accident prone? So we already know the accident happened. So we have to write P of what is already known as written in the denominator, and what they are asking will come in the numerator. They are asking what is the probability that he or she is an accident prone. Accident prone we have named as E1. Now by Bayes theorem formula, it is P of E1 into P of, we have to write its reciprocal A by E1 whole divided by, we have to copy this as it is, and we have to write the same thing for E2 because the denominator will have the total probability. So P of E2 into P of A by E2. Now in the numerator, already we have used this value in this term, this first term only the numerator, P of E1 into P of A by E1, which is 20 by 100 into 0.6. So 20 by 100 into 0.6 whole divided by, for this denominator already we have calculated 28 by 100. So it is better if I use a value directly. We can cancel these two 100, and in the numerator 6 2s are 12, and there is 0, so 120, and we have to move one decimal, so again it is 12 by 28. Again by cancelling with 4 table, this is 3 by 7.